Now it's a minute after 11 o'clock. Is that right? Here in Germany, at least, because as far as I can see here, we have guests, from a wide area from all over the world. So I would like to begin to say welcome to our friends from the Far East, from Indonesia, as far as I can see. Welcome to our friends from India, from the Middle East, from Russia. We have, of course, people here from Germany. Hallo, meine Freunde. And we have our people from Belgium. We have guests from Italy and Spain. We have our guests from the US, from Canada, Brazil, and from the Caribbean. So warm welcome to our series of webinars with the Harvard Processing Days. We are really happy to reconnect, and this is what we want to say. We are happy to have you here. This webinar series can not be a substitute for personal meetings, but at least at these days, we can come together, exchange information, and this is what we want to do. It will not be like a one-directional storytelling. It shall be an exchange of informations, and therefore I want to give a hint to the chat functions of this webinar software, which you can see. I just put some words here. Hello, everybody. It would be great to use this tool. So if you are there already, just type in a chat and let me see that you are there. There's also a questioning and answering tool, and just use that. Yeah. 1 second, I just need to tell my colleague to put off his phone as well, so that we can start really. Could you do it? Yeah, just to rip off the cable, and then we are only here with our guests. Thank you very much. Yeah, maybe we go to the first slide of our presentation here. Today we will talk about manufactured sand, and the subtitle is Quality Fractions Through Quality Screening. Yeah, I hope you see all that. There are the first comments. Thank you. Yeah, I receive your comments, and I'm happy you are there and get into action. Yeah, righty, let's go. 1 second, here we are. So who are we? I believe everybody who came in here has heard about Harvard & Böcker many times. Maybe you're coming from a mineral processing background, or you're coming from a materials bagging background. Maybe you know IBAU Hamburg for the cement terminals technologies, whatever. Here's just a few words who we are. Harvard & Böcker Niagara is the subsidiary dedicated to the mineral processing. We do solutions in the industries of mining, which means energy, materials, coal, for example, but also ores, metal mining, which means building industry. And today we will cover and go into this industry more when we talk about sands, for example, for the dry mortar industry. Industrial minerals, to convert natural raw materials to have them available for higher uses in industries, like in plastic industries, for example. Chemical industry, which we understand also the materials going into like from salt and ores to fertilizers. And in the end, last but not least, the field of recycling. What do we provide? It is our main technologies, the screening, washing, and pelletizing. And basing on these three core technologies, we do a lot of engineering work and all the necessary like transport and analyzing equipment to make complete processing systems from that. Before I come to today's topics, maybe it's nice to have also one word about who I am, not a philosophical survey, but just to tell you who's talking to you here. My name is Oliver Pralle. I'm 47 years old now, coming from Germany. I haven't made it far. I'm born in Münster, the town where we are situated here with Harbour Niagara. And I'm a mechanical engineer. I grew up in plastics machinery technologies, but for the past 13 years, I'm working with Harbour Niagara now. And in the very beginning, I became a project manager. I was a planning engineer and also like commissioning engineer in different systems like crushing plants, screening plants, palletizing plants, also washing applications. And it was like, yeah, digging in the dirt and making the systems run, and was always a beautiful experience. Beautiful in the sense like, yeah, dirty, rough conditions with a duty to making it work. Past 3 or 4 years, I switched more like into the suit and hanging around in seminars, in conferences, making presentations, going to sales. And I'm happy to have these older experiences so that I can now bring it into action. Yeah, and yeah, let's go and see what are the topics for today. The manufactured sand we are talking about today will be mainly used in dry mortars. We are talking about sand. Sand is understood to be smaller than 2 millimeters. So the manufactured sand of today will be used in dry mortars. We go into the basics of dry mortar. We will have a short look into the shortage of natural sand, which is a disaster already today. We go into the technologies that we need to convert rocks from the quarry into sands for the silo. And we will look at the capabilities Harbour Niagara can bring into it. And of course, we will go to the main question today, quality and economic efficiency. Where's the solution and how can it be derived? The basics on dry mortar, very easy, just to have everybody here on the same basis. We have mineral raw materials, and we want to use them in different mortar applications. And the word is coming actually from the Latin word mortarium, which is this anxious grinding and mixing tool we today only know maybe from our kitchen to like grind and mix some spices and herbs. But this is what it's actually about in our industry, because we want to grind materials and then mix them with certain binders like cement, quicklime, anhydride, gypsum, and put some additives into, like retardants, like colors, pigments, and so on. And by doing this in a certain amount, we receive different sorts of mortars. For these mortars, it became common to have typical distributions of sand classes. Just beginning at the finer end, it is pretty common that the material from 0 to 100 micron is at first separated to get the filler out of the materials. Then typically there is a fraction 100 micron to 300 micron. Then there's something about like 300 to 600 micron approximately, 600 micron to 1 millimeter, and maybe there are also some coarser sands. That means that before we do the mixing, we want to have a specified ingredients selection. And in mechanical processing, it's of course the characteristics of the grain sizes. The shortage of natural sand. Yeah, as I said already, we all know that the sand is actually produced by wind and weather in the mountains and in the environment. It is transported via the rivers to the seas. And already on this way from the rivers, in the lakes, in the rivers, mankind is taking this material out and using it in our industries. If the sand makes it to the seas, we take this sand out from the sea, from the beaches. And it's not about like loving beaches or not. I believe that for all the intelligent and conscious people here, we are aware that we grab a natural resource that mankind needs, that nature needs, and therefore we looked for alternatives. It looked like desert sand could be an alternative because there's an eternally wide resource, but we learned that the desert sand is too much like a round shaped to be a good ingredient for mortar applications. So it is actually widely spread, but it is too round. So what we want to do is have a look like how can we subtract and substitute the material that is actually coming from the natural sand taken from dredges, for example, and how we can now use rock quarries to crush the material down to the sand sizes we actually need in our silos. 1 second, please. I just received some hints here on problems. Let me just have a look at what is going on here. All right. Okay, I just learned that I can see the slides on the screen, but not you. I'm just looking into my options. 1 second. So here we go. If anybody can give me a hint, if you now see clearly. Yeah. All right. So there was a problem reported that you cannot see the different slides. Is that better now? Yeah. All right. I believe that the problem is clear to us now, and that nevertheless we just want to go on now. What is the way for the rocks to become manufactured sand for our mortar applications? Let's have a look. So the main point is if we have blasted rocks, that they appear in different sizes, maximum like 1 meter size, 1.5 meter size, even 2 meters. And then there's all kinds of particles smaller than this available when the rocks are blasted. But in the end, we need them in sizes far less than 2 millimeters. They need to be comminuted. The size needs to be reduced, and 1 1 meter rock cannot be reduced in size in one stage. We need different crushing stages. And we know that our crushers today have certain size reduction ratios. For example, factors like 3, 4, 5, up to 10, 12. This is the maximum. That means rock of a meter size needs to be reduced in the first stage to like 200, 300 millimeters. 200, 300 millimeter rock needs to be reduced in size to maybe a fistful full, like 50 millimeters. And then we go into the area of grinding, and we use the like hammer crushers, vertical shaft impactors, vertical roller mills to create the actual sands we are looking for. Therefore, Harvard Niagara provides the primary crushing plants to reduce the size to in the first stage. Our screens are used in secondary and tertiary crushing plants. We also provide these complete plants. And due to our fine screening systems, we end up in front of the silos. There's one specialty I want to give a hint on, and I have seen in our guest lists here that there's quite a community coming from manufacturers of vertical roller mills. Welcome again. You might know this principle here. There are today many cement plants that do not only the core business of producing cement anymore, but they became like cement plants of the future. They have a wide range of different products, and one of them is, of course, mortars, mixed cements. And therefore, we need these typical grain sizes that are mentioned already. When we now look into the area of the limestone raw mill, and we imagine that we have a vertical roller mill there, there's for the past like 20-25 years an established process where we can use the vertical roller mill not only to produce powder for the clinker kiln. It is also possible to extract grit from the head of the vertical roller mill, extract that, do a pre-unfillering by an air classifier, and then put it to a screening and fine screening system. And by this process, we do not like overgrind a material. In the same process, we produce the ingredients for our dry mortars that we were looking for. We don't need to buy them. We can produce them in our vertical roller mill. And this is, in combination, a very energy efficient process because we do not overgrind and we separate exactly at the same point and size the grits and sands that we need later on to mix our main products like the cement with the sands. What are our capabilities in this field? So, of course, we do not the whole processes, but we have certain points where we would like to be of use. So at first, we claim that we listen carefully what you need. And again, such a webinar cannot be a substitute for personal meetings. I'm really looking forward to meeting you again personally. But in the meantime, let's try this way here. And if we understand what you need and what you want, I believe there's enough experience to derive the first ideas on how to solve your problems. Yeah, if we go further on, we take your material to our test center, we do material analysis, and we do some small scale tests that we then take to our upscaling software to receive the right concepts. The concepts at first go into our process flow sheets, and later on we also look into like layout drawings, how that could fit into your plants. Of course, and this is our main business, of course, and we want to be recognized at this. We are manufacturers of screens and machinery. So we are building screens here for about, say, 80 years, at least here in Germany. Typically for the sand applications are our linear motion screens that you can see here on the pictures. For example, driven by our twin shaft drives. And today the clean alternative to that is the Haver Exciter drive that is manufactured by our friends in Brazil. It is a Haver own product, and this is bringing the power to the machines to bring the right forces to the right places. Inside our machines, there is the core technology of the woven wires. It is, I think, important to repeat again that Haver Niagara is working with Haver and Böcker woven wires. Woven wire cloth is with Haver and Böcker since 1887. There's a huge experience in this field, and there are many of our competitors using also Haver Niagara, Haver and Böcker wire cloth meshes. But we will see later on in this webinar why it is so important to have some knowledge on wire cloth and the right screen media. So here we go. I believe for everybody it is clear that for making a quality sand fraction, we need to limit the upper limit of a fraction and a lower limit of a fraction. What is a limit? Let's say we talk about a sand from 700 micron to 1000 micron. 1 millimeter. And if we do that by screening, we limit both of these upper and lower limits by screening. Screening is actually, technically from literature, the frequent comparison of the size of a particle with the size of a screen opening. And here in the upper picture, you see a square mesh opening, and this is the only way to make a very specified screening. It is not the perfect option if you just look for efficiency, if you look like throughput capacities. Therefore, we have the oblonged screen opening. They have a larger open area compared to the square mesh opening, and they are very much better if you look for a solution against clogging and blinding of screens. Here is the first hint that we need to look at the gap maybe between efficiency and quality of the sand production. In the end, it's of course important to have the right machinery parts and also the utilities here. I mentioned already that our drive gear is coming from our friends from Haver and Böcker Latinoamericana in Brazil. It's a technology also working in the mining industry for about 35 years, and this is what we also need here in our linear motion screens for the sand applications. Last but not least, let's talk about grease, and this is a story that really improved our availability of our screens, lifetime and durability, development of our own grease. So what I want to summarize here is there's a lot of self-made technology inside our machines, bringing the complete systems together. Complete systems, yeah. Out of these core machines, out of these core technologies, we combine it together with our partners and make own like partial systems or complete systems out of that. So we include crushers, we include dryers, conveyor belts and silo systems and so on, dosing systems together with our partners. But in the end, we also want to be recognized as a partner delivering only screening machines. So coming to the point now, what is this theme about innovation in the field of quality and efficiency? What is that about? I need to go very shortly into the very basics of screening. So again, what is screening? What is this process? It is the frequent comparison of a particle size. Let's see here, the size of a particle and the size of a certain opening. So is it possible that the particle goes to the screen underflow, so it is smaller than the opening, or it is larger than the opening, so it will just go over this opening? Pretty much clear. So when you look to the slide, we want to create from a bulk mixture different fractions, means a fine fraction and a coarse fraction. Pretty clear. And when we talk about screening quality, we are looking at the different fractions we produced by screening. If we have a feed, which is a mixture of coarse material and fine material, we expect that by screening, the fine material will run to the screen underflow, whereas the coarse materials go to the screen overflow. But everybody knows from practice that there will be like fine ingredients in the screen overflow, undersize in screen overflow, undesired but reality. And there will be oversize in the screen underflow, if we want it or not. So why that? Undersize in overflow appears if a small particle, which actually should run to the screen underflow, cannot make it on the screen area, cannot make it on the way from the screen intake to the overflow. So although it is small enough to be actually right in the screen underflow, it does not make it there. Why? Maybe the screen is too short. It is too small, or we don't want to pay for a screen which is long enough or large enough, or our installation is not having enough size and geometries to include such an installation. And oversize in the screen underflow can happen if we remember this particle here, if a nominal particle here would not run to the screen underflow, but the shape of the particle allows that it drops into the screen underflow, although in different other directions it would not go through. So we need to accept technically and also commercially that there will be like undersize in overflow and oversize in underflow of spec materials in our fractions. But this is not like a catastrophe. Everybody lives with it. We just need to accept the limits set by our customers, set by our recipes in our mortar mixtures. And having this in mind here, we're coming to a very interesting graph, which is helping us here at Harvard Niagara to select the right screening concept. On the horizontal axis, you see the different sizes of screen opening, the cut sizes. So from the very fine side to the coarse side, we have the different screen concepts, with direct excitement of screens, with linear motion screens, and with circular motion screens. If you want to do a cut size at, for example, 0.2 millimeters, you will need to use the direct excitement screening machines. If you want to do a cut at approximately 2 millimeters, you will end up with a linear motion screen, the typical sand screen. And if it's somehow coarser, like at 20 millimeters cut size, the typical concept would be a circular motion screen, the Harver Niagara T-class. In the upper area of this graph, you see the frequencies. So the coarser cuts are done by low frequencies. The finer cuts are done by high frequencies. Why that? So coming back to this like literature definition of screening, you do the frequent comparison of the particle size with the screen opening size. And the smaller the cut size is, the more you need to throw it and compare it. Yeah, the frequency needs to get higher. And this also goes with the vertical axis here with the amplitude. The amplitude means the throw, the stroke, how you throw the particle. And it absolutely does not make sense to overthrow a particle because it needs to be close to the screen media surface to do this comparison. A flying particle is not being compared. Yeah, with this literature, with this experience of decades, we go into a simulation software, which is, its name is Niagara Flow. It's an expert software developed by our colleagues here in Harver Niagara, and it's like upscaling and sizing software for screening machines. And over the decades, it also became a simulation software for complete processes in mining and in like crushing and screening circles where you can find bottlenecks, where you can optimize systems. And this is always used today when it's more than a screening machine, but it is like closed circles concepts where we need to find answers like, is the screen the bottleneck or is the crusher the bottleneck? How can I improve my return rates and yeah, in the end, do the best economical feasible solutions? Remember NiaFlow, it's downloadable and usable free of charge to you. And we would be happy to give more introduction to you on this here. Before I invite you to point some questions and comments here, I want to make a quick summary, which is today there is no sustainable alternative to manufacture sand by crushing and screening, because we are intelligent people, we are conscious and aware people, we like the environment, and therefore it is not possible to go this way for the next years and decades and grabbing natural sands from the rivers and the seas. Whereas the crushers and the mills do the size reduction work and the particle shaping work, it is the screens to do the quality decisive finishing. And Harver Niagara is expert in doing all the surroundings of these screens and these screens themselves, and we would be happy to be your partner in this field. Yeah, and now let's see how good this chatting and question and answering function is working. I would be happy to read some of your questions here and answer them directly. Now is your time. Okay, here's one very impressive question, which is, how are you? Thank you very much for asking. So For us, it's almost the end of this first webinar here on Manufacturers SAND. I'm feeling much better than before because it was a good working experience. But at the same time, I'm looking forward to the next seminars. I'm just grabbing here my schedule. Yesterday we saw already my colleague Jan Lamke. He explained us some good details about processing different minerals to make fertilizers out of that by pelletizing, by agglomeration. This afternoon we have Francisco dos Reis on classifying of fertilizers. Tomorrow we have Lothar. He will tell us about solutions for screening machine optimization in the entire life. That will be very interesting if you are owners of screens today and you want to look at what you can even improve. And on Thursday, we have Jan again. He will talk about the pelletizing and agglomeration in the field of iron ores. I'm really looking forward to see you again, Jan. And yeah, let's see what other questions were coming up here. I'm happy that this first problem was solved. Okay. So for the moment, I cannot see any more questions. Maybe you pointed them. We have had trouble with that yesterday, but I just grabbed my mobile and maybe I see in a different way what is the question. Here's one question from Rohit Justa. Do you also have the small tester to analyze the mesh sizes? Yes, of course. Harvard Niagara is actually manufacturer of the screening machines, but our friends from Harvard and Böcker wire weaving division, they have wonderful analyzing tools, which is like the established screening towers for laboratories, but also like the computerized particle analysis called CPA. Maybe you search the internet for Harvard and Böcker wire weaving, and you go there to the folder of analyzers and laboratory materials. Harvard and Böcker wire weaving is your partner here. But I saw your contact details. I can also come back to you after this session and send you a hint. Yeah. All right. Yeah, unfortunate that I can't see any more questions here, but I try again my mobile. 1 second. Try everything we can. All right. Is the vibrating feeder helping to reduce the oversize and undersize in reject material, or do you recommend always to have vibration feeder, or there is a special case to have it? The vibrating feeder. The vibrating feeder is a very important auxiliary to a screening machine. Why is that? The vibrating feeder is not only a transport means to like feed material or transport material from, example, a bucket elevator to your screen, or discharge from a silo to a screen. The feeder helps to distribute equally the material over the complete width of the machine just from the very beginning of the screen. So if we have the installation of a screen and we paid the full screen, we should also use the complete area from the very beginning. And using a vibrating feeder of a special geometry, we can help the material to flow equally over the complete width at the very beginning. And this makes available the whole area of a screen, and consequently it will help our capacities and also qualities. Yes, vibrating feeder is important for screening. It is not a must, but if you want to have the optimum efficiencies and capacities, it is important. Yeah. Let's see here what we have. The next one. One second. I mentioned already I became an old guy, so I can also get rid of my glasses to see better. Let's have it here. So do you know about elliptical movement and which range of openings and frequency it would work? Yes, we know about that because in the past we worked also with elliptical motion screens in the field of sand and gravels. But it was some special executions our customers asked us for. In this field, I need to come back with some more details to you personally. Yeah. The elliptical screening concept is combining like the capacity efficiency in the very beginning, where we want to bring in motion and in transport all the material, and after this material layer is reduced and the amount of material is reduced, we have the advantage of the elliptical motion to get more into the linear motion that helps us providing the qualities. Yeah, that's all I can tell you at this moment. When we talk about numbers, I would contact you later on and see what exact cut sizes and materials you have and how to optimize that there. Yeah. Let's see if we can open this again. I believe there was another question. Let's see here. A question from Bruno. Hi, Bruno. Nice that you see me again, and I'm looking forward to see you again. Is it possible to get the presentation? Yeah, so you are of course invited to download the webinar after the session. We will give you a hint when it is available, and I sent you also personally the presentation. Yeah, for good friends, we always have some good support. Nice to have you there. Is it always help to have a good distribution of material? Of course. What is the screening machine doing? So in the very beginning, I mentioned already in the context of the vibrating feeder. In the beginning, we want to have the material really widespread over the complete width of the machine. So during transport of the material over the screen, we can use the complete area. A good mixing means, yeah, actually the screen itself is doing a good mixing. It is doing a layering. Just imagine that a screen is during the transport is doing a layering, so that I just take again my particles here. The larger particles are running on top of the smaller particles, which is good because the smaller particles shall remain in the end in the screen underflow, whereas maybe the larger particles, they go to the screen overflow. A layering is taking place. Everybody who's working in bulk materials does know that. So the coarse sugar is always on top of the box and the finer sugar is underneath it. That's the same effect as vibrating screen is doing. And this is, of course, important to do a good sizing at the very end of the machine. Yeah, the machine is itself is doing this layering and mixing. Yeah. What we are doing at the moment is my wonderful assistant, Mihaela, she's giving me her mobile so I can read your questions, because our nice webinar software does not display it to me, but nevertheless, it's working. Thank you, Mihaela. What would be the optimal size for the screen for the cement industry, as most of the Indian cement manufacturers use 5 mm by 5 mm for 120 ton per hour capacity? This question sounds to me like we talk about these screens we need for sizing or limiting the size before filling and packaging of cement. So here we have ready-made cement from the silo to from the final silo to be filled into trucks, into our roto packers, into bags. And 5 by 5 millimeters in the context of cement means only a safety screening for reject material which shall not be contained in our bags in our silo trucks. For example, agglomerates, screws, like parts of machines or protection gear or so. Reject screening means that the particle sizes, in this case cement, maximum like 100 micron, is by far smaller than the mesh opening. It is not a classifying, it is a real protective screening. And here it is just necessary to select the right mesh size according to what our customer, the cement producer, is asking for. Yeah, he does not accept agglomerates larger than 5 millimeters, 8 millimeters, or 10 millimeters, and this is decisive for the mesh opening. And we consider that we need only very, very small screens, so that the cement much, much smaller than the mesh opening is flowing through these openings just like water, and that only these oversized undesired particles remain in the screen overflow. And here we cannot make a classification calculation. Here we work on the basis of decades of experience in this field, and we have our lists. And as this question was asked from our colleagues from Harvard, India, I believe we can forward to you these lists on experiences. Yeah. I saw you who put this question, and I would come back to you here. Yeah. 120 tons per hour is, of course, possible to screen on only 2.5, 3 square meters. Yeah. All right. Yeah, it's like in school, yeah, homeschooling. Our children get to know that the last weeks. I hope everybody coped with that very well. You cope with the situation of our pandemic, and you stood healthy. You stood healthy. You and your people are well, and you stay well. And yeah, maybe Mihaela has got another question. Let's see. We still have some rotary type screening machine from Harvard in India. Do you have a comparison over linear screening machines? Any advantages you can explain? Yeah, that's a good question. So Harman Niagara is not producing rotary screens. By rotary, my understanding is now that we have a circular screen, a round screen of one layer or multi-layers. And actually, I like these screens because they have a very compact design and you can do a number of cuts in a very compact way. But there are, of course, advantages for the like vibrating screens in a rectangular shape. It is, of course, very good to control the materials. And I see today the main aspect in maintenance costs, and downtimes. Imagine in these fine cuts of like 300 micron, 500 micron, 600 micron, we have quite thin wires. These wires get worn and torn by the time, and frequently, as a protection, we need to replace these wire meshes. So we need to open the screens and replace them. And here, my understanding is that we can do a quite quick replacement in a very short time, and the replacement costs are quite low because you can get these standard wire meshes configured also with the right tensioning units in your markets, whereas the round screens need to have a certain like tensioning service that you tension them on these round frames, and therefore you need to have some replacements always on stock, send them to your services, or you pay in-house services. And here I see a big cost advantage and handling advantage for these standard wire mesh materials in a rectangular shape compared to the round shaped machines. Yeah. Let's see. Alex, is there any standard metallurgical test work that potential producer needs to do for the process? The rest I cannot read. Metallurgical test work. I believe this question is pointing to metallurgical test work that can go into the field of the particles itself, the desired particles, the sands. Yes, but also to the metallurgical questions of the materials used inside our machines. And yes, of course, this applies as well. Not so much maybe in the field of mortar applications, but if you look to similar applications like glass sands, it is very typical that, of course, they look into metallurgical questions. Imagine you have here, again, my glasses. Everybody who's using glasses, he wants to have like a clear view. The glass shall be clear, there shall be no brownishness, and this brownishness in glass, in a building glass, is coming from iron oxide. So in our glass sands, there shall be only very, very few share of iron oxide. Where is it coming from? It is, of course, coming from the quarry itself, from the silica sands itself. But these suppliers, these manufacturers, try to avoid iron or to bring iron into the process from the processing machines. So they do not want to have like metal wires as a screening media. They do not want to have like wear protection coming with like hardened steel, because all these wear and tear coming from the machine equipment, and not only screens, but like bucket elevators, bunkers, silos, and so on. Everywhere there is erosion, wear and tear, the particles go into the actual product. and they contaminate the sense itself. And in the end, you melt these glass sands and you get this brownishness into the glass, which is undesired. I hope this is meeting your question and I understood it right. hopefully. Yeah. Yeah, I believe we could come to an end now. My clock says we are together now for approximately 60 minutes now. I did not expect so much reaction and interest. I'm very, very happy about that. And yeah, I'm already looking forward to coming back to you with another theme and issue. Maybe you want to write me something we could inform you about. Again, this is not only about screening, it is also about palletizing, it is about contributing to you with services and engineering works. And I see that there are a lot of partners here in our community that do similar things, and just give me a message or a call, and yeah, it's possible again to travel inside Germany, inside Europe, and of course very soon also worldwide. And I would be happy that I can also see your face. And I will now close my camera and you get rid of my face. I say bye-bye, stay healthy, and keep your good mood at any time. Greetings to your colleagues, families, and friends. Bye-bye.